Hello, Morris. How are you doing?
I'm fine, thank you. How are you?
Perfect? Not perfect because I wanted to order your book and I can only pre-order your book. So
Oh,
you were,
that's a
yeah.
bit strange. I'm now holding up a copy of it. I will send it to you if I have to, but I'd rather obviously that you bought it.
No, I
Uh,
would I would like to buy it. So
mhm.
in my world, it says minus 15% Java generics and connections collections fundamentals and recommended practices, and
Uh-huh.
will be available in Germany on July 29th.
Well, I don't know. I didn't realize that the post was so slow to Germany. I mean, I think in the UK it's available now.
Yeah,
There's
because you are not the European Union right now. So
that's right. Presumably it has to check pass biosecurity checks
biosecurity
to make
and is
sure.
maybe rerouted through India, and North Pole and comes from the other side. So this is why I have to wait longer. But I already like, the agenda, the index from the book. This is what I can see on Amazon. And today I'm just curious about, or I would like to refresh my knowledge about generics.
Okay.
And this is one of the, Java generics and collections. So we can focus today on generics. And so at the beginning of Java, there were no generics. So it means if in the beginning of Java, we had just object strings or whatever, but there was no way to specify a type for a container. I think this is a problem. The problem we have are collection structures and stuff like that, and method parameters. So the question is, why the generics were introduced in Java? I mean, they were needed, but what was the so a little bit backstory of the generics, if you know that.
Well, yes, certainly. Well, when you couldn't type the contents of a collection, to take that as an example, because although there are other generic types, and maybe we'll get on to talk about the most important one, the most important other one. The main use case for generics was seen as collections,
Mhm.
and the problem with not being able to type the contents of a collection, in other words, if you have a list, you couldn't explicitly say whether it was a list of string or a list of integer or whatever. The problem was sold as being one of type insecurity. So you put a bunch of strings into a list of string, and then you accidentally put a number into a list of string. There's nothing in the language that would prevent you from doing that. But when you try then to read all the contents of that list in the expectation that they'll all be strings, you're going to get a class cast exception, because when you retrieve the contents, everything was stored. The static type of everything that was stored in the collection was always object.
Mhm.
And so
And we had to cast a lot, right? So back then,
and
so
so then, in order to be able to use an element of a string in the type that it really is, you would have to cast it, and then
mhm.
you would get a class cast exception if it was of the wrong type. Now, I mean, my view is that this as a sales point for generics is that this was always oversold. I don't think people had that much trouble with
Mhm.
type security of collections. However, what they did have trouble with, and what generics did fix, was just the lack of readability of the code. It's very difficult to maintain code containing a lot of collections when you have to hold in your head or somehow record, maybe in the identifier for the collection, the type that it's supposed to contain. And this gets a lot worse, obviously. It's okay to say to name your list string list if it's
Mhm.
supposed to contain strings, but that's not so easy if it's a collection that's going to contain many sub-collections, and each one of these has must have its type recorded, and so on and so on. So the big gain, in my view, was that you could then immediately see, by looking at the type of a collection, exactly what the contents of it were supposed to be,
Mhm.
exactly what type
And,
they were supposed to have.
and my impression is the reason why we got collections so late is because at the beginning of Java there were no collections actually. So Java shipped without collections in the first place. So and without collections, there was no need, maybe not an obvious need to have generics, right? And generics uh, is more complexity. And at the beginning, I remember Java was sold as the simple alternative to C++. So I think if they would, and as also I remember the C++ template mechanism was criticized at the beginning by Java developers as being complex, and then the collections were introduced afterwards. So at the beginning of Java, actually in my projects, I had to evaluate various collections frameworks, third-party collection frameworks for various companies. I remember there was Rogue Wave, I think, one company
Rogue Wave.
Yeah.
I'm not sure. Yeah, you might well be right. I don't remember that. I mean, I think for Java, up until Java 1.2, talking about ancient history, which was the first time. Now I think it's now called Java 2. The first time that Java really became a usable platform in a commercial on a large scale. Up until then, we had some collections which are still actually on the platform, which were things like Vector. Vector was the ancient correspondent for ArrayList, and
Hashtable.
For a hash table, that's right. Yeah, hash table with a small t. So we did have those. We did have those things. So they could have had generics attached to them, but the problem was, and then this is it's good that you mentioned C++. The problem was that once you have the language without generics at all, you've got to make a big decision when you introduce generics about, are they going to be represented at runtime? So this was the big question, and people still argue about it now. Are we going to reify? That means represent at runtime the compile time generic types, and so this wasn't resolved by the time Java 2 came out with the collections framework that we have now, that we still know, even though it's a long time ago. But that was the kind of big introduction, and there was a scheme was put forward in the pizza paper, which I refer to in the book, which was actually written. One of the authors of the pizza paper was Phil Wadler, who then went out, who later I managed to corral to write the generics half of the generics and collections book, and he's still a friend. So with three other people, Phil put forward the pizza plan, the pizza scheme, which was that the types, the generic types, would be available at runtime for checking, and of course for maintainability and all that, but they wouldn't appear in the they wouldn't appear in the bytecode. They wouldn't be reified. So the idea of this was, once you've used them to ensure type security, and to make sure that everything is consistent, you don't need them any longer. Now, that isn't quite true. There are uses for them at runtime. You can't do an instance of test on see whether you've got a list of string. You can only do an instance of will only tell you that you've got a list.
But because the effect of that during compilation, the types are lost is called type erasure, right?
It is indeed that it is type erasure, and it was very controversial at the time, and it still is to a certain extent. So the big advantage of this was that you wouldn't have to alter the bytecode. The bytecode for an erased, for a generic class which has been erased is exactly the same as for a class with raw types, that is, without any generic information at all. So actually, this could have been introduced straight after Java 2, and it was very slow to be introduced because of the Java community process at the time was quite unwieldy. And one of the vendors, and I think it was IBM, but I'm not absolutely confident about this, and I don't know the politics of it, but the Java community process was slow and unwieldy, and it took between Java 2, which was 1998, and Java 5, which was like 7 years later. I think the pizza paper was in the early 2000s, and it took like 3 or 4 years before this scheme was actually adopted into Java 5. I don't know if does that help to unravel the history a bit.
Absolutely. I mean, these are actually important. This is important information because right now the process is faster, so we can see a perspective how it was at the beginning of Java. And now it is actually better than before, right? Because
I'm not. I think that's the case. I mean, I'm not sure how the JCP operates now. In that case, certainly it was very unwieldy.
JEPs. This would be our JEP, I guess, right?
Yeah.
Right now, it would be not
It would
JCP.
it would be a JEP now, and the process. I think you're right. It would be more streamlined, and I think the discussion would probably be more rational. I don't think it would depend.
And you
so
remember the
much on
problem? The problem with JCP back then was that the Apache Harmony, if they were involved, they always say no, because there was some problems with licensing of the TCK in all the projects. So I would say the JCP process back then was, my impression is, it was highly political, and today the JEPs is more pragmatic. This is my point of view. So how it works. Mm-hmm.
But I think that's fair. I mean, I do hear a lot of. Obviously, people will never be happy. So I hear discontent about the way the process operates now, because it is more streamlined, and it's also there's less politics, and it's probably not very democratic still. But I mean, we get good results. So democracy is not always the only thing.
Yeah, you said something, and it occurred to me the first time that the hash table with smaller t.
Yes.
So this is actually a mistake, right? Because the hash map. Yeah. This I never saw this. So actually, it's the first a big inconsistency in Java.
Yeah.
That the hash table should be T, capital T, to have a camel case, but it's hash table. This is actually interesting. So,
well, it's not really interesting. I mean, remember that the developments in Java 1.0 and in the JDK 1.0 and 1.1 were very, very hurried. I mean, maybe they went to the opposite extreme later on, when it was many years between releases. But in the early days, getting Java established was a matter of a race to the marketplace. So quite a lot of mistakes went in.
Yeah, but this one is an interesting one. So I all these years, and I never saw this, and now I see this clearly. And yeah, thank you. So this was already actually
there you are.
worth for me to to have a podcast with you, because a small thing, which is and hash table right now you could use it, but no one uses it anymore. The problem with
there are reasons. There are reasons not to use it. There are many reasons not to use those legacy types, but one of the most important ones is that they're fully. I'm going to say they're fully synchronized, but they aren't in a satisfactory way. But basically, you're paying a huge overhead to get a kind of inadequate thread safety out of them. And they didn't make that mistake when they introduced the modern collections in Java 2. They made them non-thread safe, because people have been complaining we're having to pay the overhead for a kind of inadequate form of thread safety with Vector and Hashtable, and most of the time we don't need it. So let's not have it, and that's what happened in Java 2.
So I remember the discussion back then, and it was the new collections were sold by removing feature, which was type safety, and this was also a controversial topic back then.
Well, they didn't remove type safety. There was no type safety.
Not type safety. Thread safety is what I wanted to say. Thread safety, not type safety. Thread safety. And the hash table was retrofitted, so now it is compatible with hashmap. So now you could hashmap map, not hashmap, map. Right.
I think yes, Hashtable now does implement the map interface. Yeah.
I'm wondering why it's not deprecated, because I think there are still very old projects, but maybe because of AWT or something internally, right? So this.
Oh, you mean right? I couldn't tell. You'd have to ask Stuart what the reason for that
Stuart
is.
Douglas? Okay.
Stuart Marks.
Dr. Stuart Douglas. Sorry, this is. I couldn't ask Stuart Douglas anymore. I could ask him about 42. You're right. And Stuart Marks is the right one. He was already on the podcast, and we had already in a very interesting discussion about deprecation.
Yeah.
Okay. So we had a type erasure, which means during compilation process the types are removed, and you said type reification. Reification, yeah. Which is the opposite, right, of type erasure?
Well, sort of. I suppose sort of. I hadn't thought of it that way. So to reify is like it's from the Latin, and it means to thingify. Raise is a thing in Latin. So reification means to make something concrete.
Yeah.
So I guess you're right. I mean, erasure means to remove something. I always thought of reification as actually just preserving the type and passing it through, rather than actually rather than making something new. But I guess the word does mean like making something concrete. It was just an idea, and now we're going to make it into a solid thing. Yeah.
But if we got, let's say, a reification JEP, then it would mean for me that the types are now in the bytecode, right?
Yes,
this would be what if we had a Java reification generics JEP. So for me, if I will read it, I say, okay, now we have types back in the bytecode. So sort of is the opposite of erasure, because in erasure, the types are actively removed from the bytecode, right?
Okay, actively removed from the bytecode.
Not removed. They are not included, right?
Yeah, that's right. They're not. They can't be removed because they were never there.
Exactly.
And now there was, for a while, I mean, for quite a long time, I remember a lot of discussion about whether reification would be done. I mean, initially I was told that they couldn't figure out how to do it. I mean, there's a big problem of binary compatibility, because the great advantage of generics as it was introduced with erasure means that you don't have to worry about bytecode compatibility, because like the binary compatibility, because the bytecode is identical. So now if you have different bytecode for generic code as against code generated from raw types, you've got a problem of making sure that everything interoperates, and you've got, obviously, the JVM has to know about these two different kinds of code. So that would be a significant overhead, and I think it's been really this has been fairly thoroughly argued, and it looks to me like the decision has come down very heavily that it's not worth doing this. And reification is not going to happen, and I recite some of the arguments about that in the book.
Yeah, exactly. This would be my next question: whether you think it will happen. But
it's not good. I think it's extremely unlikely in terms of the gains that you would make from it. This is how the argument goes. In terms of the gains that you would make from it, like you're going to be able to write instance of on generic types, and a few other things as well. The cost, the opportunity cost in terms of the effort you're not going to be able to spend on other things is just too great.
And generics, if you use generics, you can generify, I think this is the right term, generify the type, constructor, methods, and even static methods. So there are multiple levels of generification, or how to call it, to apply the generic feature on Java elements, right? So you can apply generics on class level. You can apply generics on constructor even. You can generate.
How could you apply it on a constructor? I'm not sure.
And methods.
Methods can be generic. Yes, absolutely. I mean, so they can have. So the way I would describe this is, I mean, if you think of a type, I mean, it's easiest to think of collections, right? No. So a list is a generic, and it has a generic type. Or it has a type parameter rather, so you can have a list of string or a list of a number or whatever it is. So it's a list of E. Now you also can have generic methods which have a different type parameter. So that's entirely possible. So you could have a method which takes a list of E and an argument of another generic type. So that would be a generic method. You can't generify constructors in the same way, because a constructor has to construct an object of the generic type of the class that it's with the parameter that class has been given. So it can't be independently generified from the generic type of the class.
I post in a chat the code. Maybe we call.
All right, let me have a look. Let me have a look at the chat.
We should call it differently, but I think it could be called as a generic constructor. Wait a sec. I have just to make you a little bit smaller, because you are also full size. And now I will.
Where is the chat? Where's the chat? Oh, I got it. Okay, probably.
This is like this is a generified constructor, and I would say
So you're going to get an entry
with a constructor with generified return type, if you will.
So what is so what's the declaration of the type entry here? What's the class declaration look like?
Oh dear, wait a sec. I just tried. The class declaration would look like. I was just curious whether it is possible. It seems like for me, and the class the entire thing looks like that.
Well, remember it's only 8 o'clock in the morning here for me, so
yeah. Oh, sorry. So we too early for you.
That's all right. Oh, right. Okay. So I see what you mean. I was thinking of a type with
how to call it, a constructor with generified return type, right?
Yeah. Okay. That's that's an unusual thing to do.
Very unusual, but I was just curious whether it's possible, right?
I think so. So yes, I think it is. You know, I've never seen that before, because it's not is that a useful thing to do?
No, I was just curious to know how far can we go.
You're going to restrict the type. I mean, that's kind of a weird thing to do. Honestly, Adam,
but I think it is possible.
If what you wanted, so let's just take this apart for a minute. What you're doing is you're constraining the type that can be supplied to the constructor.
Mm-hmm.
So you're saying what I want to do is I want to make an entry that can contain an element. You've declared entry, and you said the only kind of thing that I want to be able to put into this entry
mm-hmm.
is something with a particular constraint.
Mm-hmm.
But you're only putting that constraint in the constructor,
mm-hmm.
right? You're not putting it in the class declaration.
Mm-hmm.
Now, if you actually wanted to make use of the fact that your elements are constrained in that way,
mm-hmm.
right? Why wouldn't you put that into the class declaration?
No, I don't know. This was just
because a user of the class might want to know that.
Yeah, I was just played with generics and was interested in what's possible, and I saw
it looks like that's possible, and I think the reason I've never seen it before, and I didn't immediately jump on it
because I was okay.
It's not a very useful thing to do,
because generics for me were the class level, then method level, then static methods, often utility methods, and I was just curious: can actually constructors have generics? And it seems like, and I say, okay, then maybe, right? So I would also have to think about this. I was just curious, okay, so we can forget the constructor generification, and this is not how this looks like. Public and then generic expression, and we can have and then the typical constructor call, and but it's interesting, right?
I think you might be able to. I'm thinking about it now. You might be able to make a case for it if there was something special. You wanted to do something special in that constructor that you could only do when the type had been constrained in that particular way, even though it's possible to construct an object of the entry type that isn't constrained in that way, because you might have other constructors that aren't generified in that way. I guess you could have a specialized constructor that would do special things with that, but it's kind of it's a little bit weird, because it's not really the main purpose of generification. You really want the type to be constrained rather than just one constructor. But it's interesting. I'd never thought of it before.
So it means now you are forced to write the 3rd edition, right, of the book.
I think you have to consult my publisher and my family before you get agreement to that.
Yeah, we can postpone you can after the release of the podcast until you're done. But interesting. But the simplest possible case, of generics is that we have generic on the class type and how to call it properly, and then inherit the types to all methods or of some methods, right? This would be or how you put it. This was my rough description, but how you will put it. So
you mean like what advantage?
The simplest possible and most useful use case for generics. This is like you have collection of type, and then it is inherited to all methods, add, put, and so forth.
Well,
Yeah.
well, you can assume, for example, I mean, like you can assume consistency. So, for example, if you've got a collection of some type E, then all of the methods can depend on the fact that
Exactly.
that every element will be of the same type, and if you constrain that type in some way, so you want it to be a subtype of number or something like this, then all of the methods can rely on that. Yes.
So it means so the standard way is I have a collection of dukes, and which is a mascot, and this add or put and remove automatically inherits duke. It means if you write Java program, you can only put duke to the collection and never a string, because this is collection of dukes, right? So this would be the simplest possible case. And what I forgot to mention before collections, the problem was not actually the cast. The problem was what developers did, or what I also did is I got the object, and then I checked with instance of, is the object of the specific type? Then I cast it, and if it was not, I throw a exception. And the question is to know which type of exception it is. And sometimes it was even a custom exception. It meant back then in enterprise project, there was lots of ceremony dealing with how to call it, raw collection types, right? So like with objects. So there were 4 lines of code just to fetch a duke from the collection. Right. And with generics, you don't have to cast. So this is a huge gain for readability, right?
It's a huge gain. It's a huge gain for readability. I mean, the cast, of course, really does take place,
but not in our code.
I mean, well, the compiler. Well, yes, it does take place. It does take place in your code. The compiler inserts it.
You don't see this, right? It's not in source code. It is in bytecode. Yeah, exactly. Exactly.
Absolutely. So the reason that might have all that ceremony if you didn't have this would be, I mean, you can always, in the old days, you would retrieve this thing and you'd do the cast, and you don't need to introduce a custom exception. If it isn't of the right type, if somebody's broken the integrity of your collection and put the wrong thing into it, you'll get a class cast exception. But that's a runtime exception, and it may not be what you want, and perhaps you want to take some special action because this alien object may actually signify something with semantic meaning in your code, and not just a bug. And so then that's where the ceremony comes in.
What's occurred to me that the compiler over time evolves not only to a compiler and more to a code generator, right? At the beginning, it was 1-to-1, and then it generates more and more Java code before it actually compiles. You know what I mean? For instance, the cast, if you think about the cast, this was before source code. And now the source code is linear, and it generates additional bytecode.
I suppose you could look at it that way. I mean, another way of looking at it is that compilers always are code generators. But I mean, I suppose this is what syntactic sugar is. I mean, if you think about records, for example,
syntactic sugar, exactly. Syntactic sugar is actually code generation more or less, right?
Well, I mean, think about records. I mean, the records are this really wonderful feature. I think everybody really loves them.
Yeah.
But I think behind the scenes, as far as I know, I think they're implemented by vanilla classes. The constraints are all there imposed by the compiler as to all the things you. I mean, records are a great example of how you can improve a language feature by actually stopping people from doing things. So records are just classes in which there's a huge number of things you can't do, and so that's actually really, really helpful. But the compiler has to do a lot of work to ensure, first of all, I mean, since there's no, I don't think there's no runtime feature that corresponds to records, so it just has to generate the class that you would have written, and then enforce all the constraints that prevent you from doing the bad things.
So generics. So we can put generics on Java type. We could put is also on method. So on Java type, you can generify a Java class and then use it in methods. Or what you can also do, you could say, I just use it in methods. So you can say, the parameter is the return type, right? For instance,
Yeah,
you
for
could have a
example,
static method.
Yeah.
And you can even combine this. So you can have these generics on class type plus override it on specific methods, right?
Mm-hmm. Yeah.
And you could have static methods, of course, which is always, you can have interfaces with static methods, which for its utility classes with generic types, right?
Yes. Yes, this is correct. I mean, the way I think that it's introduced in the book is basically there are two types of things. There are generic classes and there are generic methods. But you're right.
Okay.
But the generic methods could be a mixture. You're quite right. I mean, it's quite common, in fact, for methods to mix the generic type that they've inherited from the class that they're in with a type that's also imposed as well. So yes, that's quite common. So I guess you could say there's three kinds of, to put it most simply, there's three kinds of generification. There's generic classes, and then two types of methods. One that mix those the type from the class with another type, and then the static methods, which just have generic types on their own. So yeah,
interesting point. So if I have an instance method, not static one, then could I also add my own generic? I don't even know. Do I have to reuse the class generic, or I could introduce?
You don't have to reuse it. It'll be in scope. So
it'll be in scope, but I can have both, right? It can have additional generic from the instance method. Okay.
Yeah, absolutely.
And in static, it's not possible to reuse the class method.
You haven't inherited one.
Yeah, exactly.
Because you're static.
Yeah. And the problem is in Java we have inheritance, and then it becomes a little bit more interesting, because what you would like to do is you would like to restrict maybe the types, or you have to, and there are interesting terms, right? There's this invariant, covariant, and contravariant. And I think you maybe describe it in this book as well, right?
Yes, yeah. Absolutely, yes.
I was not able to buy your book. This is the problem. So I have to.
I have to tell you though, I probably shouldn't put this on the podcast. You can read some of this stuff, although I've rewritten a significant amount of the explanations of the first part. If you want to read the earlier version, it's not at all difficult to find PDFs on the
This is what I know, but we don't like to encourage us. I think people should not search for PDFs, and because there could be no virus inside or whatever, they should absolutely buy the book and wait a little bit. And July 29th, this is actually the right approach, the most secure approach, right? In these days.
Indeed, and also the most ethical one as well.
Yeah, absolutely. Yeah. So
But anyway, what I was going to say was,
so far we discussed invariance, right? It was just one type and ends over. So this is invariant, right?
So the reason. So if you think about, supposing you want to work on an array. Array typing is not invariant. In the early days, before we had generics, we still had the problem of writing generic methods. So supposing you wanted, for instance, to write a sort method that would work on arrays prior to collections. Well, I want a sort method which is going to work on any comparable or anything that can be compared.
You're right.
So the problem now is that this method is going to have to accept an array of any subtype of comparable, and anything that implements comparable. Otherwise, I'm going to have to write a different sort method for every collection for arrays of every different type. I have to write a sort method for arrays of integer, which will be different from the sort method for arrays of strings. So what I need to do is I need to be able to write a sort method that will work on arrays of object, and therefore since arrays of objects have to since arrays of integers have to be it has to be possible to supply those to that method, which is expecting an array of objects. Array of integer has to be a subtype of array of object. Was that clear?
Yeah.
Right. And that is called covariant typing. Because integer is a subtype of object, array of integer is a subtype of array of object. Now, we don't...
As an interesting part, right? This is parallel hierarchies, right? An array of strings is not necessarily a string. So there's there's like parallel universe, right?
I guess so. You wrap an array around it. Yeah, absolutely. Now they did things differently. Because that can lead to because something that you don't actually very often find is something called an ArrayStoreException. When what you try to do is you retrieve from an array, because you can actually pollute it. But this allows you to pollute an array. You can declare an array with a compile time type, a static type of, say, I don't know, an array of let me think of it. Oh yeah, an array. You call it an array of integer. You declare it as an array of integer. Then you upcast that to being an array of number, and then you can put a double into it. But the original array, the arrays remember their unlike collections, arrays do remember their runtime, their type at runtime, their component type at runtime. So trying to put a double into this array, which is actually knows that it's an array of integer, is going to produce an ArrayStoreException.
That's actually a cool hack. That's a cool hack. What you do is you have an array of integers, and integer is a number, so you can upcast to number, and then then you have another array of numbers, and you put a double, and then you get ArrayStoreException.
Yes, absolutely. So this code compiles all right, but it produces an exception at runtime. So we don't like that. We wanted to prevent the same.
This is a cool idea for a short. I will have to try it and record it, because this is actually a really nice hack. So yeah. And how they call? Is there a name for this hack? I mean, this is just an upcast.
Well, yeah, no. I mean, it's not exactly a hack because because it's a problem. So I don't think there's a name for it. The name for it is something that we don't want to have happen, and the name for it is bad thing, and we eliminated that, or they eliminated that with generics. So generic types are not covariant in the way that I described. So a list of integer is not a subtype, although integer is a subtype of number.
Okay. This was the reason why this is actually the reason why we have the super and extends in generics, because they didn't want to have.
This reintroduces covariance. A list of integer is not a subtype of list of number. But so in order, because you do want covariance for the reason I described, because you want to be able to have these generic methods, they reintroduced it with wildcards, with bounded types, and a list of query extends number is a super type of a list of integer. So query extends number is some type. You don't know what it is. It defines a range of types. It defines some fixed type that you don't know, some unknown fixed type within a range from number all the way down to the type of null. Any subtype of number. It's some unknown subtype of number, and that reintroduces covariance, because integer is a subtype of that type because it belongs in that range, and so it now allows you to write generic methods again.
So just the type is invariant and extends is covariant, and this with extends behaves more or less like an array.
Well, more like it, yeah. But it's important to say, and we would spend a lot of time. I mean, a good part of the generics section of the book is given over to the various incompatibilities between the array typing scheme and the generic typing scheme. They really don't fit well together at all. And that's
the longest chapter about generics, or?
Yeah, it's certainly the most difficult one. I mean, all the problems that arise from that. Yeah, absolutely.
And we have also a contravariant, and I assume this is super, right?
Yeah, sort of. Yes. So it's not difficult to understand in principle what the idea of extends versus super is. I said that that a type in query extends.
And queries are question mark, extends, whatever, right?
So, query is a question mark. So if you say question mark extends, you're defining a type range which is bounded above. It's any subtype of X, which obviously also includes X, all the way down to the type of null, which is a subtype of everything. And then and query super is bounded below. So it's any supertype of X. So it's any member of a supertype of X. So there's a nice symmetry between them.
Yeah, and the symmetry is really useful for PEX. Producer extends, consumer super, right?
Yeah, well, that's right. Yeah, so yeah, absolutely. That was Josh Bloch's acronym, and in the book, Phil invented this idea of the put and get principle. So it's the same kind of thing. Yeah.
Okay, then tell me both. It's interesting. So
so the put and get principle says that you can put into a so it's like producer extends, so you can which way around is it now? So it's the put and get principle.
I won't cut it out. So which one is one, right? So I will keep it in the podcast.
All right. Excuse me one moment. I will look up the put and get principle. It's always helpful to have.
So I don't have your book, so I cannot cheat. This is my problem right now.
So the put and get principle says when you want the get and put principle, use an extends wildcard when you only get values out of a structure. Use a super wildcard when you want to put values into a structure, and don't use a wildcard at all if you want to both get and put. So that's the same as the PEX.
Get and put would mean per reference, right? I'm putting something in the method, and or what is doing put and.
Well, if you want to be able to, so the idea is if you've got I actually have a diagram in the book which I think explains this better than you can explain it in words. When you want to get values out of a structure, you need to know what the type that you're getting out is, and so because extends. Because an extends range is bounded above. Supposing I say that I'm going to that I want to get something out of a structure which is defined on query extends number, then I know that if I call get, if I take something out of there, I know that it's going to be of type number. I mean, this is the I'm certain of that. I mean, the one thing obviously that I can be certain of is that when I however a structure is defined, if I get something out of it, it's always going to be a type object. But that's not very useful in many cases. If I want to be more precise about it, then I need to have used an extends wildcard, a type that's bounded above. If I want to put something into a structure, then I need to have some kind of guarantee. There's no point in using an extend wildcard because I can't put it into if I have a value of a type that is a subtype of number, say, I can't put it into a structure defined on query extends number because what that structure is defined on some fixed subtype of number. But what I can do is if I know that if I have a range which is bounded below, then I can put it in there because bounded below means that it must be some supertype of number. Then I know that whatever the supertype of number is, I can put a number into it. Was that clear?
Yeah. My mental model. You know the pattern tolerant reader?
I don't think I know the phrase. No.
Tolerant reader is a microservice or web pattern. It has nothing to do with Java. And what it says is that if you build a service, it basically means accept crap and deliver quality. So it means as a parameter, whatever format you have, I don't care. But what I this is not Java method. It's just an abstract construct. Let's say we have a REST service, HTTP, and accept JSON whatever. And but what you return is some quality object. So you can for the generics, what they remind me of is the parameters. They can accept whatever it is. It has to be the type, and this is the type I'm working with. So if you have a number, I can put float, double, or whatever. I don't care, because I'm mostly interested in the number. But if I return out of from the method, the user of the method cannot know all the types. They can only rely, on the restricted type. It means it's more strict, so I can put more and return less, right?
Okay, I see. I do see the parallel. By the way, I'm quite skeptical about this pattern, because that's what led to the mess that HTML is. The HTML parsers were tolerant, and they accepted anything. And the result is.
But this is a thing. This is a controversial topic, because you remember XHTML? They tried to fix it, and it broke internet, because if you try to do no type safe, this is not actually. It will be never accepted, or XML. So I think. But this was like, how my mental model is. If you have the parameter, and it has to be something which looks like a number, and I'm happy with the number. So it can be any type. But if I return it, I cannot do this, because I cannot say, whatever it is, because the user of the method has to rely on something. So it is more strict. This is somehow my mental model, and therefore parameter extends and produces consumer super, right? This is.
And I see the parallel, and I think it does apply. I mean, it's a good motivation for why you would want to see it that way. Yeah.
Because of casting as well, right? So if you get from the method, let's say, the number, how we would do it, we would do whatever is number, and you return number. Then you can say, okay, this is a number, but you cannot cast it, to integer, float, or whatever, because you have no idea what's came in. You know what I mean? So if you have a method, let's say sort with a number, let's do the thing from. So my mental model is sort. So as long as it's a number or comparable, I can sort the thing internally. I don't care what it is.
Mm-hmm.
But if I return the thing, I mean, what I know, it is comparable. But I have no idea how many implementations of comparable exists. So I cannot just accept everything. You know what I mean? So I could cast, of course, but I cannot say this is comparable or something more specific. But I mean, the impact, what has is sealed types, right? So with sealed interfaces, I could actually know how this actually sealed. If you think about this, sealed interfaces could have impact on generics, right? Because if comparable would be sealed, I would know that there are just 3 implementations and could be more loose on the return type. Could be.
Yeah, I guess that's right, and I don't actually know. I mean, that the compiler could actually be intelligent enough.
Exactly.
Whether it is or not, I don't know.
No, but it was cool to see, right? So this is the 4th edition of your book. But if you think about this, because the compiler, if you have, if comparable would be sealed, we would know in advance there are only these types. So you could be more loose by return types, right? Actually, I don't know how to call it. It would be like some loosely.
Yeah, it's not so much you could be more loose, but well, in fact, I would put it the other way around. If you knew that you there would be a possibility of doing some kind of that's interesting. You could do some kind of a case split on the possible types, because there's only a finite number of implementations.
Exactly.
Yeah. I'd have to think about that.
Okay. It's interesting to talk with you. This we have totally new approaches to generics. So, So now, what's also interesting, Now, yeah, you looked up, right? So now you're in an endless loop. But this is interesting. So think about this. Of course, I have to invite you back because we have to talk about the collections. Actually, generics was just a small part after the book is published, of course, or available in Germany at least. Generics and reflection. So strangely enough, you can actually ask via reflection what's the generic type, right? So this is interesting because we said type erasure, but you can still ask via reflection what generic types they are, right?
Yes, this is correct. So although we say that the erasure removes the generic type information from the bytecode, but that's kind of not exactly correct because it is actually preserved in the it's preserved in the class metadata. So actually, you can ask questions about what you just can't use them at runtime in your code, but by reflection you can find out what the generic generic type parameters have been supplied to a generic type, and you can ask a lot of other questions about it as well. So yeah, this isn't. I don't think this is greatly used. I think it might be used more in by tool vendors then it's not kind of normally used in production code very much, I don't think. But there's facilities for doing that. Let me have a look at some of the things you can do. So we've got, it's probably more interesting for most people to think about the class, the generification of the class. Which is quite a puzzling thing.
But I had recently a use case for that. Interesting enough, very recently, last week actually. Are you aware of service loader? Of course, right? Service loader.
Yes.
Yeah, and really strange thing. So what I wanted to build is I have no dependencies. Actually, it's this MCP. This is like a little bit pure Java implementation of like AI connector called Model Context Protocol. And what I wanted to do is I have like the base protocol, which only is able, to do the basic things. And I would like to have the extension in another jar. But what I didn't want it to do is that my extension jar knows the connector jar. You know what I mean? I wanted to avoid having an API. And I searched actually for interfaces within Java which define such an extension point. And for my purposes, Java util function was the right thing because it is actually like reflective method is whatever you like. But my function method has specific signature. So what I did is I implemented a service loader which searches for all implementations of Java util functions. So this was declared, Java util functions is source main data.
Okay.
And then I searched, but I wanted to have more type safety because I was not interested in everything. I wanted to give additional hints to the user. Look, you have the function, but the generic types are not right because it has to be function of map and returns a map. And this was actually where I use it, and it worked nicely because I got said, okay, your generic types of function is not the right one, do this, right? So this was one recent use case of that. And I was actually surprised that it worked at all, but it worked well. So now I have a generic mechanism. You can implement plugins for my thing without knowing what I'm actually doing. There is you only have to be in class path. And interesting part is what was missing in Java. I searched for annotation which describes, a method. So like a name and parameters, but there's nothing there. And I didn't want to create my own because then I would have the same problem that the plugins have to know my API. And I wanted just, to use Java SE core. But this is my recent use case, and it worked really well. And I say it is cool because I talk with you today. So maybe I present you another use case of generics,
That's really nice. Have you written that up? I mean, have you?
This is in my GitHub repository. I will put it to, and this is in the tutorial how to use that, and yeah, I had a bad feeling at the beginning because it's a hack, but it works well because the cool story is what you can do now. You have a folder with my jar and how many jars you like, And because of Java, you can have a class path with the star, right? Since Java,
Right, yes.
there's this CP, and I have a generic plugin mechanism without any external dependencies, and it works perfectly. Actually, I have to say.
That's very good. Yeah, absolutely. I mean, yes, the world should know about that.
Yeah, I will write it. I didn't want to mention this because you are it's like if I mention it, you will say, okay, please don't publish the podcast. But if you're happy, I'm happy, right? So this is.
No. I don't know. I don't have that feeling at all.
Okay, perfect. Because what I like is just use Java SE first before I reach out to other libraries. And with that, in my projects, if I able to do that, my projects, they are not dependent on external things and never have to be patched except Java.
Right.
And this is actually a very important for long-lasting projects in enterprise. And and this works actually well. So thank you.
I think of you as actually the kind of primary the primary proponent of that approach. I mean, I've seen you talk. I've seen you not explicitly say that, but I've seen you talk at conferences where you put forward solutions that are based on core Java concepts in a way, and emphasizing in a way that I don't see other people being interested in.
Yeah, I'm also a consultant, but what I find out is you don't have to add additional libraries to get a project. Sometimes if you are minimalistic, it's also fine for my client. So and also if you think about this, it is good for vacations because I can focus more on core Java and don't have to learn the next big thing, because if Java is enough, everyone is happy, and I don't have to learn things which die. And we are long enough in the Java ecosystem. There are lots of frameworks which are not popular anymore. And this is waste of, of if I learn something, it has to make sense or be long lasting. And this is also my selfish motivation to focus on kind of standards or core Java and whatever. And Java is actually great. There are lots of stuff inside. This is actually a lot of stuff which is not used, which I stunned actually. Right?
Yeah. No,
System logger. You use system logger? Java Lang system logger, for instance?
I don't know.
Built-in system logger. You don't have external frameworks. You can just use it. It works well. Facade. You don't have to use log4j, or SL4j is just built-in Java Facade, for instance. Okay.
Right.
We covered with generics, I would say we covered the biggest part. Sorry for the excursion to my service loader, but
no, that's very interesting. I'm going to go and look at that.
So we have and I interrupted you because what you said is the most useful thing is the reflection on class level, right? This is
Well, yes. So but also the hardest thing to understand, because it's sort of difficult to understand how. I mean, it's the primary use case for generics is, of course, collections, and it's kind of harder to understand what it means to parameterize the class, class. So, what I've figured out eventually is that if you provide if you can provide a type parameter to the class, then effectively you are you've got compile time information about what type of class it is. So there are different ways in which you can get a class object in Java, as I'm sure everybody knows. You can just call what's the name of the method that
class for name?
Yeah, class dot for name. But what that gets you back is a reference to a class where you don't know what the type is. So that's going to be, so you have to say, well, I've got a class of question mark here. But if you use a type literal, so I want to get string dot class, then what you get is a class object. Sorry, it's a class reference, which at compile time knows that it is a class of string.
And so to make everything clear, you get instance of a class. And
you're going to get an instance of a class in either case.
Yeah, which is an object, and object is also a class, right? So this is.
Sure.
Now everyone is confused, right? This was because if you think about this is always meta circular, right? So you have class for name, you get a class, which is an instance of a class, not an object. but the class is an object.
Yes. Yeah. No. Well, everything's an object. So
Yeah, of course.
you're right. It is a bit hard to think about. It's also slightly harder to think about because at compile time you have a reference to a class object, but you don't know what the type of the class object is. So if you've done class.for name, you've gone and searched the class path, and you found something with the right name, but the compiler has no way at all of knowing what the type of that. The type of that thing is. Whereas if you say, I know what class I want the class object for. So if I want to use it for reflection, then you say, I know that it's going to be a string or a service loader or something like that. And you say, I have thing dot class, and then you'll get a class literal, which is at runtime exactly the same object. But at compile time, you can make much more use of it because you know what it's a class of, what the type of the class is.
On that note, there is an additional method. It's called cast. You can have class and invoke cast to cast stuff on reflect on meta level to avoid the real cast. Right. This is the interesting part. Yeah.
Yes, absolutely. So when you have these things, you can do a cast. What else can you do? There's a number of methods.
And another is assignable from. Is assignable from.
That's right. Yeah, and you can also do an instance of as well, and using that. So
wait a second. Instance of? No, because instead of class is a class, right? You cannot do is class instance of.
It's assignable. Well, actually, sorry, you're right. Is assignable from is effectively.
Is this like instance of on meta level, right?
That is the thing. Yes, that's that method has that effect of asking whether it's an instance of. Yeah.
So and there are also raw types. This is just the question mark in generic, right?
Well, not strictly speaking, no. I mean, there's a kind of subtle difference.
Okay.
A raw type has simply no type arguments at all.
Okay.
And there is a perhaps there shouldn't have been, but there is a difference between a raw type and a type which is parameterized on the question mark. So the question mark is actually query. It's a shorthand for question mark extends object. In other words, it's some fixed type from the entire range of types. We don't know what it is, but it is a fixed type. A raw type just is outside of the generics universe altogether.
Is there a difference between a raw type and how to call it question mark type, or how to call the question mark type? What is the term for it? Wildcard? No.
A wildcard, yes, a wildcard.
Is a wildcard? Is the question mark the wildcard? This is the
question mark. The question mark is a wildcard, yes.
Okay. Absolutely. Is there a semantic difference between wildcard and raw type?
An unbounded wildcard. There are syntactic differences, but I don't think there's any semantic differences between them. So there's there's a point at which we actually discuss whether or not okay, so I'm a bit vague about that. I think
we will postpone it, so no problem. So next time,
let me just have a quick think about that. If you can edit this out of the final version, and let me just see what I said about this because it's gone out of my head. Okay, conclusion 98. So where are we? 98. So there's something is in my mind about this. Okay, so the question is, should unbounded wildcards have been this consistent? So a reifiable type in Java is one which does not. So a reifiable type is one which can be translated directly to bytecode. And the one kind, of course, the wildcards with that. So if you have a bounded wildcard, then that is not reifiable. The reason that it's not reifiable is kind of obviously because you don't know what the type is at compile time. It's unknown. But they defined a list of an unbounded wildcard as being reifiable. Now, the reason it's reifiable is because it is the same semantically as a raw type, and so that complicates the definition of reifiable types a bit. So the answer to your question, I don't know how this is going to come over in the podcast, but the answer to your question is there is a syntactic difference between them, but there is no semantic difference between them. Yep.
Okay.
And it's possible, and there's an argument for saying that allowing the syntactic difference between them might actually have made life more difficult and complicated it.
So it would mean if I would use the wildcard, it would mean I know generics, but I don't care. It's more like, but if I don't use generics at all, it would be suspicious nowadays, right? So
it absolutely would. It absolutely would. So it's certainly true that you'll start getting unchecked warnings.
Exactly.
Which and unchecked warnings in general are a bad thing because they they're not always avoidable, but it's important that if you ever get an unchecked warning, you should figure out exactly why it's happening and be confident that it's unnecessary. The compiler can't always tell whether or not it should be giving you a warning, and so it will give you a warning to be on the safe side. You can figure out sometimes that what it's complaining about is actually quite safe, but unless you do that, then there's a possibility that it's right, it's right to warn you, and that you will get a runtime. You'll get an exception at runtime.
Perfect. I think we covered whatever interests me. So I hope we covered the at least basics for generics, right? We had invariants, covariants, contravariants, wildcards, raw types, and reflection. I think these were all right.
We've certainly talked about all of those things, that's for sure.
Yeah, perfect. And if there is more, we all should buy your book. So I would buy at least the preview. I can pre-order right now, and we'll wait until it arrives from non-European countries. And
like Britain, you mean?
For instance, and maybe there will be some tariffs on it as well. But it is 15% cheaper right now on Amazon for me.
I really don't understand why it would be more difficult. I suppose it might be something to do with the tariffs because it's coming from America, I guess. So
okay.
It's published by O'Reilly.
You might be right. Maybe they are waiting what happens. They cannot ship it because they are not sure, whether
the EU is in a more dicey place as far as tariffs.
That means your book is more dangerous than NVIDIA cards, So there's like so much knowledge in the book, so we cannot ship it, right? So this is like the shipping restrictions, right? Exactly.
Right. It's a security problem because it's effectively it's a munition.
Exactly. Exactly. So it was pleasure to work with you. I'm really inspired to work with you, to talk with you, and I'm really inspired about lots of new ideas. Actually, lots of new ideas, and I just use generics without thinking about it a lot. So before this conversation, I thought a little bit more. So I guess it's actually really interesting, and I have to invite you back in some time after I have the book to talk about the other stuff in the book, and I'm already, looking forward to the conversation.
Well, thank you very much. I've enjoyed it a lot, and I look forward to it as well.
What's the name of the book? Can you just?
It's called Java Generics and Collections.
Second edition is the important one.
Second edition, absolutely. I wouldn't.
Yeah, and maybe third, because there were some corner cases which are not covered, right?
Right. I do have a vacancy for an agent, actually. So
okay.
You're first on my list of candidates.
Okay, thank you. Thank you a lot, and see you next time.
Yeah, see you next time. Thanks a lot, Adam. Cheers.